Happy Fabrication Friday, everyone. Welcome back to this week's edition. This week, we're going to change things up just a little bit. Normally, or at least thus far, all of our videos have talked about the process of building something, of putting something together, repairing something. And today, I just wanted to take a little bit different tack because although it's nice to know how to build something, I would argue it's almost even more important to know how to evaluate something, evaluate the quality, understand whether or not it's going to fail, right? And when you think about a welded object or something that's been fabricated using a welding process, that is critical. I mean, if you look around your daily life, there are hundreds and thousands of welds that you rely on every single day, from the welds holding your car together to the welds that might be on various fixtures around your home or garages. Okay, and so I think it's really important not only for fabricators to understand what makes a good weld, but also it's helpful to the average everyday person because if I'm honest with you, there's a lot of stuff that's sold and people pay a lot of money for with, frankly, garbage welds that I can't believe have not failed in some cases. And so today I want to spend equal parts time just on kind of consumer education as well as helping out some of you fabricators out there get a better handle on what you're actually looking for. Okay, and so today we're going to spend some time talking about the basics, right? We're talking about the basic types of welds, basic types of joints, the parts of a weld, and then we're going to start looking at what you can look for when visually looking at a weld and some basic weld evaluation. All right, so let's dive in to basic types of weld joints. Now, no matter what welding process we use, no matter what welding product, no matter what you do, there are about 5 basic types of joints, right? There's roughly 5 main different ways that we can put 2 pieces of metal together, and here's what they have. Over here we have an isometric view, or close to an isometric view, 3-dimensional view of an object, and over here we have the section view, or a cross section, right? So if we were to cut this object in half, cut it in half, what would that look like, right? First one here is called a butt joint, This is exactly how it sounds and looks. We're simply taking 2 pieces of metal and putting them end to end, right? Probably one of the more common joints that beginning welders work on. It's probably one of the easier welds to do, one of the easiest to set up. But with all due respect, it's maybe not the most strongest, because in reality, we're simply putting a little weld nugget in between there. If that weld nugget is not good enough, we have a high likelihood of failure. So the first one is a butt joint. Okay? Second one we have is called a lap joint. Very similar to a butt joint, except we have our pieces overlapped and welds either on either side of that, one or both of the sides. Okay, this is what a lap joint would look like. When we're looking at a lot of repair jobs or a lot of other applications, laps are the way to go. We see a lot of laps out there. Next, we have this thing called a T-joint. A T-joint. All right, in this case, it's just like it sounds. We have 2 pieces that are joined in the orientation of a T. Typically, it's a 90-degree angle, or some variation of a 90-degree. It might be a little bit either which way. But then it's welded. Here's what that T-joint looks like in a 3-dimensional view. And next, we have an edge joint. So it's kind of similar to a butt joint, except rather than joining the 2 pieces on the narrow side or on the short side, we join them on the long side. Okay, so this might be where we have 2 plates that we need to put together somehow. Here's another piece of what an edge joint might look like. You see this a lot, or it can be seen a lot in various flanging operations. So where we need to put a flange on a pipe or something of that nature. And lastly, we have a corner joint. Yeah, at first glance, it looks a lot like a T-joint, right? Except our pieces come together and form a corner. Now, sometimes those corners can be completely open like this, where the two inner corners meet and we have a big gap in the outside. They can have some variation of half lap or overlap, but in the end, it's a corner joint. Okay, so 5 basic types of weld. I guarantee it, if you go out in your garage, your home, out in daily life, you will start seeing these everywhere. Where I work at Hutchinson High School here. Just walking throughout the building, I probably encounter hundreds of these every single day. Wide range. So every single weld we do can be considered, well, most likely can be considered one of these 5 main types. All right. And so that brings us into the next piece of the puzzle, and that's figuring out what makes up this weld. All right. And now at this point, I am going to be getting into a really micro level. Okay. We're going to give you just the basics, and we'll go from there. All right. So we're going to look at a couple section views here. Okay. First, we're going to look at a section view of what we might call a fillet weld. Okay. This is called a fillet weld. The fillet weld is characterized by being used in between a corner. We see fillet welds in corner joints. We see them in T-joints and the lap joints, okay, primarily. All right, so I've got a few pieces labeled here. I've got my base metal here, base metal down here. This is exceptionally blown up. This is essentially a full 8.5 by 11 sheet of graph paper. All right, so first of all, some parts. All right, or how I've laid this out. So in a fillet weld, we take our pieces, we lay them next to each other. These dashed lines represent the edge of each of those pieces. All right, this highlighted part represents our weld nugget. So after we're done welding, that is the piece that we've added. That is the piece we've added to our joint. All right, and so there's a few parts of this that are pretty key. All right, the first one being your toes. Okay, the toe of the weld is where that weld nugget meets up with your base metal. All right, that's probably one of the most common areas to see issues with your welds is at the toes. Okay, next we have what we call the face. The face is the visible part of that weld. When we look straight on at that weld, what do we see? And that is our face. Okay. Next, we have what's called a throat. Okay. Now I'm going to draw it over here because our throat represents how deep that weld goes in. All right. So if I were to draw a dimension line roughly here, okay, it would come out to here. This would be your throat depth. Okay, so your throat depth. Okay. Lastly, we can see there's a slight zone in between our dashed lines here and our highlights. That's what we call the heat affected zone. Okay, or HAZ, the has. All right, that heat affected zone, the size of that heat affected zone is really dependent on how hot we welded this, depends on the thickness of metal. There's a lot of factors that go into this, but without a relatively large heat affected zone, we will have issues. Okay? I guess there's one others that we can call in here. We can throw in the weld root. Okay, that weld root is here at the deepest part at which that weld fused in. So from the face to the weld root, or from the face down to the deepest part, that's called your weld root, right? And so when I'm evaluating students' welds in the shop, that weld root and the heat affected zone are a couple things that I'm looking for. All right. So basic parts of a fillet weld. Next, we're going to look at some basic parts of what we call a groove weld. Okay. Groove weld has all the same parts, just in a little bit different setting. Now, a groove weld is really held in between is held in a butt joint. So two flat pieces put together. We have several different types of grooves. We can have what we have drawn in here, a square groove, right? Where the two edges of the material are considered or are 90 degrees and slapped up next to each other. We can have some sort of beveling where that groove comes in at a bit of an angle on one or other sides. I mean, I have a lot of different types of grooves there. Again, we have our base metal. Our yellow highlights represents our heat affected zone. And these dashed lines represent the hypothetical edges of our material. All right, so again, very similar. We have toes. Again, your toes are where that base metal or where the weld joins into the base metal. Okay, we have a face. Okay, we have a throat. The depth of that weld. All right, we have a root, and in this case, what we've drawn in here is a root opening. In this case, these pieces aren't butted up perfectly next to each other. They aren't butted up tight. They have an opening there. All right. With our root opening, sometimes we can add a backer piece where it's a third piece of metal that sits in the back and holds that root in. Not always needed, but one of those types of things. Okay. We have our has, our heat affected zone. Okay. All right, and lastly, we have something called reinforcement. Now, reinforcement I'm going to run out of room here. Sorry about that. Reinforcement is the measurement from the top of the metal to the top of the face. It's a measure of what we call convexity or concavity. Okay, how convex is that face? How far up above that the top of the steel does it extend? In a lot of welding applications, there's a limit to the amount of reinforcement. Like some standards, they call for a max of 1/16 of an inch of reinforcement. Okay, and so we have to understand how to weld and how to go about doing what we do in order to stay within those limits. All right. Now, these are some basic parts of our weld. Now, if you were to go in and really take a deep dive, you could spend a lot of time looking at the metallurgy of this. You could spend a lot of time looking at the engineering of this, because there are a lot of mechanical and chemical forces and characteristics going on here. This is a very simplified view. This is something similar that I teach my high school students as students, because this is about the bare minimum that you need to know in order to be an effective weld evaluator. All right, if you do want to go more in depth, I would encourage you to do so, because it is kind of fun, but it is a pretty deep dive. And my goal has always been to keep these videos relatively short and digestible, you know, around 15 minutes or less. And so with that, I think we're going to call that a wrap on this first part. There is a lot here. There's a lot to understanding what makes a good weld good. And even in this multi-part series, we're still only going to scratch the surface. All right, and so today we really laid the groundwork. We talked about the basic types of weld joints and the parts of the weld. Next week, we're going to start diving into how we go about evaluating this weld and what we're going to look for. Along the way, we'll get into a little bit of discussion on what causes various issues with welds, and just a real bit ad hoc on how to go about fixing them. So look forward to that next week. Next week, we'll be back talking about methods of evaluation and what we're looking for. Until then, have a happy Fabrication Friday.